Welcome back to computer science. So, we learned a bit about indentation and code blocks yesterday. So, code blocks are kind of just a concept. Um, at this point, they're a little arbitrary, but I'm sure they have meaning later on. But code block, every time you indent further to the right, that's the beginning of a new code block. That's the first line of a new code block. And then if you have, all of them in the same indentation level, without changing further in or out, that's one code block. Then if you go in again, that's the start of a new code block. Colons denote the beginning of code blocks, and then everything that's spaced all the way as far left as possible, that's the first code block, or that's code block 0. It's all considered one code block. For whatever reason, the outside's a little bit weird like that, where the whole thing is one block. That's just my understanding currently. You can use any number of spacing or tabs to indent, but you need to be consistent. They recommend not mixing tabs and spaces. It can cause indentation errors. So I just stick with the recommended 4 spaces. I think that's fine. So code blocks, they're defined by their indentation level. Colons denote the beginning of a new code block, or like the next line will be the beginning of a new code block. I think that's basically everything. Series of statements grouped together. One question I do have is, if you've got, say, a code block and then indents further, and then another code block, that's not the same code block. No, I don't think so. Okay, I'm gonna continue learning now, and then I'll be back to recall what I learned in a little bit. All right, we finished that unit on code blocks and indentation. One, I think, note was basically special cases where subsequent lines with the same indentation level that were indented together, that they do not denote a sequence or a code block, and that's like within containers or variables, like for example, multi-line strings. Like the acceptable range for how long, like how wide a program can be, is between 80 and 120 characters typically, and it's best to aim for about 20 or 80, which is best practice. So sometimes if you have strings that are longer than, you need to wrap them. In that case, you'll use parentheses on the first line and the last line, not parentheses, and then you'll use quotation marks on every line of the string. In that case, that string, they're going to be indented at the same level, but it's not a code block. And neither for like dictionaries where you have multiple lines with different key value pairs, lists, tuples with multiple lines, sets with multiple lines, those do not count as code blocks. You need to have a colon at the preceding line to denote a new code block. So it's just, that's the note. And that way of wrapping multi-line strings is known as implicit line joining, I believe. So that's something we learned. So now we started the next unit, which is on membership and identity. So membership operators are actually pretty simple. They are in and not in, and they check if an element is within a container, and also can be used for checking strings for substrings. So they output Boolean values. So if an element exists within a list and you use the in membership operator, then it will output true. The other one is not in. For dictionaries, it only checks keys, it does not check values. And for strings, you can check if a string is a substring of another string, or if it is the same string. That's what you can use with the membership operators for strings. So, good, returns a Boolean, good, check a string, substring, good, or the same string, good, keys only, good. Acceptable number of text columns range from 80 to 120, good. Best practice 80, good. Not all grouped lines of same indent are code block. strings that wrapped, list, six, tuples, sets, implicit line joining for strings. All right, boom. Another session complete. I'll be back later to do another session to continue learning more about membership operators and identity. So talk to you in a bit. Welcome back to computer science. Earlier today we were still looking at no. Yes, we looked a little bit at code blocks and indentation. Then we started looking at membership and membership operators. And that's all I'm going to do for a big picture overview, because we're going to really cover stuff tomorrow as well. All right. I'm going to go ahead and start back into the textbook, and I'll be back to recall what I learned a little bit. All right, guys, there was a lot in there. A big conceptual breakthrough, or piece I didn't understand, then I got it. So we got into identity operators, which are is and is not. Basically, this is determining if two variables are referencing the same object. So yeah, that's essentially the same thing. So it's checking if the IDs are equal, not if values are equal. That would be just an equality operator or an inequality operator that checks values. This is checking identity, aka the object that's assigned, the object that's assigned to the variable. So here's the conceptual thing that was difficult for me was, so when it's going to be simple now, but when you assign two variables to each other, so you say x gets y, now x and y are the same. These two variables are referring to the same object in memory, and they will stay that way no matter what, unless, or if it's a mutable object, they're going to stay the same. So if you say x equals or x gets y, and y is a list, well, now x and y are both referencing the same list. So if you say now index 0 at x is 5, well, now index 0 at y is 5 too, because it's the same mutable object that they're referencing. So that's interesting. But if it's an immutable object, then if you make any changes to the immutable object, they're now unlinked, because if you say x gets y, and then you say y plus equals 1, so you increment y by 1, well, it's immutable, so it's going to it's going to get rid of that old object. Maybe not get rid of it because it's still attached to x, but now it's going to create a new object that y is going to get, so, or assign to. So yeah, output's a Boolean, just like the membership identity. So and there's also this concept of pre-creating object / object caching / some other term as well. And basically it seems that Python reuses and maybe even pre-creates, makes a bunch of potential small values in memory that can be reused. So they have a variable or a slot, an ID in memory, a location in memory that's always like 1, essentially. And so anything that's ever equal to 1, it just assigns to that, rather than creating a bunch of different random a bunch of different ones, potential ones or small values. It just has like, I don't know what it is. Maybe this is different by interpreter, but maybe there's just, for example, -10 through 1 for integers. And so anytime anything gets assigned a value of -10 to 1, it already goes to a pre-created ID object, and location in memory. So that's interesting. It's like an optimization thing. All right, that's it for today. Definitely getting more complex concepts than we've been doing. This is getting a lot more nuanced and interesting. Yeah, tomorrow is Saturday, so 45 minutes is all I think we got for tomorrow, so that will be the last day of this week, and we'll be into week 8 on Sunday. So that's it for today. I will talk to you tomorrow. See you.